Our next step, write cylinders. Okay, so basically we're looking at a soup can. That's what we're looking at. And I've got a beautiful video again from the same guy I had before, which shows you how to make a net out of a soup can, which I think is just so cool. Here we go. Look at this. And look what the net becomes. There's our can, and then he breaks it apart. And look what you have, which is really neat. The label of the can is actually this rectangle here. And your lid and your base, there's your base and there's your lid. Your lid are two circles. So circles, you know, are pi r squared. But how do you figure this guy out? Well, that's the height of the can. And if you don't believe me, watch the video again. Here we go. The height becomes, okay, so he's going to rotate this. The height of the can, the height of the label. Boom. There it is. There's the height of the label. Excellent. Okay, so let's go back to our notes here and let's figure out a few things. So we're figuring out a few things. Here we go. There's our top and our bottom of our can, of our soup can. There's the height of the soup can, which translates into this height right here of the label. But my question is what is this guy right here? What is this length here? Because if we could figure out that length, I know that the area of a rectangle is length times width. In this case, the area is going to be this height, whatever this height is, times, well, whatever this guy is. Well, the difficulty comes in is remembering, where does this guy come from? He comes from right here. Look, he comes right from around the soup can. And you know and I know that's called the perimeter or the circumference of a can. And that is 2 pi r. Interesting. So this is times 2 pi r. So your width is 2 pi r. There's your height. So your circumference is your 2 pi r, the distance around the can, and this is your height. So your area is this times this. Works out really, really nice. So the height, right, of the can times 2 pi r, where the circumference around the can. The area of the circle on the top and the bottom match. Those are both pi r squared. So all in all you have to do is add all of this up. You have 2 circles times pi r squared, oops, right here, plus this lateral face being the height times 2 pi r. Look at that. And there's your surface area of your cylinder. So they may show you a slightly different formula, and the formula is right here. The surface of your cylinder, there's your top and bottom circles, and then there's, your lateral face. Remember, it's the label of the can, which is the lateral face. So let's use this in calculating a question. Here's a beautiful question. Calculate the surface area of the cylinder shown. All right. Answer is appropriate units to its nearest tenth. So that just means to 1 decimal place. Okay, surface area formula. There we go. There's the lids, pi r squared, times 2, right? Because there's a top and a bottom, plus that lateral surface, which is 2 pi r h. Okay, 2 pi r, there's the circumference around, times the height of the can. All right, so let's put that in there. 2 times pi times the radius. Radius is 14.6. No, that's the diameter. Divide that by 2, you get 7.3 inches. Okay, so the radius is 7.3. That's going to have to be squared. Okay, plus your 2 times pi, 7.3 times the height, which is 16.8. Do these calculations separately because, of course, bed mass rules. Okay, right? Brackets, exponents, multiplication, division, then addition, subtraction. All right, so let's do the exponents here. Let's do this first one. Let's do this one. Bring up my calculator. Okay, clear it from the last calculation that I did, 7.3. BEDMAS tells you to do brackets and exponents first. 7.3 squared. There it is, giving you 53.29 times our pi. Okay, times by 2. Okay, there is the top and bottom volumes, or I should say surface areas of our cylinder. So this works out to be 334.8. 334.8 plus, now let's do this lateral face. The lateral face, again, let's clear a calculator. There's no exponents to worry about here, just lots of brackets. So we'll just go 2 times our pi times 7.3 times 16.8 and hit enter. And we've got a huge 770.569. Holy smokes, 770.569. Let's add these two things together. Add that to our 334.8, 334.8, bada bing, and we got something that's pretty close to 1,105.4. 1,105.4. Now, what are the units? Again, we're dealing with area, so all our units have to be squared. This unit is in inches, so this is going to be inches squared. Okay, I got a couple more questions down here for you to do. You can go ahead and do those questions, but I think that summarizes it up for you quite nicely.